This lecture is going to be about image. And so my plan is to go through key image type. We're going to talk about image array, image matrix, binary image, byte array, range, byte image matrix, double array, double range, double image matrix, normalized double array, range RGB values, mixing them, image array, and LED matrix. And this sheet, I titled this sheet hand in that I'm going to demonstrate by writing on this. And so the experience is more I want to emulate is like as if I'm writing on the whiteboard, writing on the blackboard. You can follow them, watch me. And some of you might take notes. It's up to you as well. And I make taking notes easier because you can download this blank Excel sheet. You can just, if you have a right device, you can write alone. Many of you have, based my experiences, many students have just tablets and other hardware they can use. It's not that hard for you to follow along. And then afterward, with by hand exercise, I will use kind of small examples. As you can see, pretty soon there's very small number of elements I can actually write. And then, but then in order for that to become practical, so we'll move down to trying to repeat some of the calculation, but a slightly larger scale, so that we'll not be able to write by hand. But you can see that how you could scale up. And then in Excel, I like that how I can write formulas. So you get really, really close to writing actual implementation in the future. So I'm going to show you how I can write in Excel formulas, writing some almost like writing code, and then to enhance, to strengthen that learning experience for you. Okay, so let's go back. I will talk about image array. And the way to understand is that for computer vision, a lot of times it comes down to for computers to understand what's in the image. And you have a series of images, it's become video. And so when the images come into this computer vision system, and they say there's a file. When you read file or read the image into the memory, it usually come into this array. So for instance, we have an image array, very small image of only 6 values. So my coming this value like 4. I don't like black. Let's just use red for now. Okay, and erase this. All right. So for just an example, 4, 3, just 5, 2, 5, 6, 7, and there's a array of numbers that represent image. And so then you have to define this. Okay, this represent an image. And then for simple image is image is actually a 2D thing. To be able to convert array, first you want to convert into matrix. And the information we need to convert array into an image matrix is the width, the image width. In this case, image width is 2. So with that information, I'll be able to say, okay, every time I have a row of pixels, 4 and 3, I'll wrap the row around after the width of 2, and then have a second row, 2 and 5. My third row is 6 and 7. So I have this image, matrix representation. And if we have a different width information, for instance, 3, they will repeat the similar wrap process, but a different parameter. In this case, the width is 3. So I can do it by hand. It will be 3, 4, 3, 2, like this. Okay, and then second row will be 5, 6, 7. 5. This is pretty straightforward, but again, we start with something simple. You'll get pretty hard very quickly in this class when we get into later content. So don't worry about it. If you feel like, oh, I'm insulting your intelligence. No, I'm not. I'm just trying to start small. Okay. So, and the binary image is that instead of just integers or some real numbers, we'll like to have value between 0 and 1. So usually a binary image result of applying sort of a condition or a filter. So in this case, what if we look at all the pixels, 4, 3, 2, 5, 6, 7, but only want to see, okay, greater than 3. And so the first location 4, yes, it's greater than 3. 3 is not greater than 3. We get 0, 2, we get 0, 5, 6, 7. How about 5, 6, 7? It's all 1, 1, 1. They're all greater than 3. So we get a binary image like this. Another type is instead of just arbitrary numbers, I just write some random numbers, 4, 3, 2. But then if a byte array, that would specify a particular data type. If a byte, well, how many bits are there in a byte? Is 8 bits. And what would be the number? What's like a range of values? So a range for a byte In this case, it could be from 0 to 2 to the 8th power is 255. So it's a 0 base. Okay. So if I would just simulate, come up with a byte array. So the largest value I can put is 255, and smallest is 0. It's integer, assumes integer. And then I can fill in any number in between. So it's how I would generate a byte array by hand, something like this. But I don't have any negative number here. 0 is as small as I want to get. And then, so if we turn that array into a byte image matrix. So now we look at the width is 3. So I'm going to do 255 and 0 and 128. This is my first row. And to wrap this row, we're going to do a second row. This is 42, 0, and 30. So 42, 0, and 30. Okay. So far, so good. Okay. Nobody is telling me any audio video issue. So we can keep going. All right, so we have byte image array. Another popular type is called using double. What if instead of using a byte, I'm using a double? And what do you remember the range of a double? So double can be negative and be positive. Also can be really small, can be really large. So this is minus 3.4 e to the 38th power, and max is plus 3.4 if we allow positive and negative numbers. So this is not something you need to remember, but it's more about in practice. With double array, you'll be able to put number like 0.5. You can put number like minus 0.03. You can have some really large number, but usually because precision is not exactly 4305, but 4305 and dot something something. And could be negative large number, and can be 0, and could be 3.2. Just this is an example. And following the similar process, how do we convert a double array into a double image matrix? So we'll wrap them by rows again. So in this case, with the 3, follow similar process. I copy down minus 0.05, minus 0.3, and 4305, and this minus 3.44 and 0 and 3.2. So I just converted a double array into a double image matrix. Okay. All right. And another common thing we do is we wanted like to normalize this double array. When we normalize a double array, our goal is that instead of some really large range like this large range, and we just want to limit to 0 and between 0 and 1. And this quite commonly used, especially when we get to a probability map as image, which is all probability values, and it would be between 0 and 1. So for instance, we can have 0 in our normalized double array, could have 0.4 and 0.3, 0.2, but nothing negative. It's 0.1, 0.3. This is the example of a normalized double array. So you can wrap them into a matrix if you know the width as well, and following similar exercise we did already a few times. Okay. Now, next I want to talk about some colors. You might have probably studied this, or you've developed any website working with CSS. You know this, but it's more like a review. So if we have a byte, and byte, just a reminder, is 0 to 255, right? And how do we get a red color? So we have 3 different channels: red, which is RGB, green, and blue. For red, we're going to have a highest intensity for the red channel. These are one of the 3 primary colors, and so we have 0, 0 for the other one. So for green is obviously this one, for 255 for green, and 0, and this is 0, 0, 255. All right, so this is pretty simple. And for, I believe most of you already knew this. So white is high intensity for all 3 channels. It looks white, and black is like no intensity at all for all 3 channels. And we'd like to represent it using a normalized floating point, and it will be 1, 0, 0 for red, and for green will be 0, 1, 0, and then move this cursor away. All right, so okay. I'm using my keyboard to move this around, but I realize it's distracting. Okay, now it's for blue 0, 0, 1, white is 111 and 000 for black. Okay. And now if we mix this RGB channels, and you can get some kind of other color as well. So I just picked 3 very popular colors. And as a review for yellow, this is mixing of the highest intensity in red and green. So get yellow. And cyan is the green and blue channel mixing. And magenta is the what is it? It's a red and blue, right? Red and blue, almost like kind of purplish. So for this one, and if you map that to the float representation, normalized float, by the way, not just any float, normalized float, normalized between 1 and 0 is 1, 1, 0, 0, 1, 1, and 1, 0, 1. So far, it could be kind of not that hard, right? So okay, hopefully. And then now I want to talk about is that, well, we've been talking about the image array so far, just each number represent a pixel. Now we actually need multiple numbers, more than one number to represent a pixel when we actually like to represent a color image. A color image has 3 channels. Again, RGB is the most popular, most well-known color space. So in this case, we would like to suppose we have the red, yellow, cyan, and black. So have 4 pixels, but use 12 values to represent this 4-pixel image. All right. So for red, another decision you have to make is that we know we're gonna use 3 of this pixel to represent the color, but we have to agree upon the order in which RGB are arranged. So of course, the most popular common is just arranging RGB. But in some other systems, other library, they might make some assumption of how RGB arranged. It could be BGR, for instance, in OpenCV library. That they assume these colors are arranged in a different order. Okay, so they just for this simplicity's sake, here we just follow the most typical order: RGB, RGB, RGB. So every 3 value is a pixel. And so we write down red. We have information we copied down from earlier on. So it's going to be 255, 0, 0. Yellow is 255, 255, and 0. And cyan is 0, 255, 255. And black is just 0 and 0, 0. So this is my 4 pixels RGB image array. And we could rearrange them into something small like this. But it's hard for me to write 3 numbers in it. I'm trying to squeeze it, but it looks very ugly. Okay. Anyway, so this is one way I will rearrange this image array into 2 pixels. And when we actually like to actually display them, and if you so the way that if you look at the screen at this moment and you have lots of pixels, but if you happen to have a microscope with you, you probably don't, but you happen to have it. Imagine you really trying to magnify your screen you're looking at right now. At the end, you're gonna see that each pixel actually there's 3 different lights, LED matrix kind of like every pixel is 3 small lights here, and they will be controlled separately and trying to mix the color you actually want. For instance, for this is going to be what do I have here? This is going to be red. This is going to be yellow when I arrange them into a matrix. This is going to be cyan. I just kind of write down some words for to remember. Okay, black. Okay, and then so I have 4 different pixels. And then I kind of put them in this shape so that look square, even though they have 3 different lights. So the way that I would draw this, I would be just draw something larger like this. So the first pixel is red. So we have 4 color in this red light. But for the other one is kind of black. Okay. And then for yellow, we have, what do we have? Yellow is red and green. So we'll draw red again here. Change to red. This is my red light. And green, change to green. Do I have green here? This is green. Green and blue will be black. So it kind of look like this. And for cyan is the mixing between green and blue. I mean, green and blue. Let's try green. So green is fully bright, and blue is, let's use which one? Blue. This is blue. Okay. And then for red is black. All right. And for black, it's like kind of something like this. And if you draw enough of this, I only drew 4 pixels, but imagine you drew a megapixel picture, a million times of this, and you zoom out, they actually will look like individual red pixel, yellow pixel, color will get mixed in together. So anyway, so we're gonna move over here to the Excel side to see how we can apply some of the concept in a slightly larger scales. Okay, so let's just review what I have gone so far. We talked about the most basic the data representation. When you receive the image from the file, it'll come in an array. But in your code, most likely you have to rearrange them into that kind of matrix. You can imagine there's like kind of a for loop, double for loop to go through width and go through height. And then, but then you have to know the width in order to compose them, arrange them into a valid image. So, and then we eventually would like to mix them in colors so that it looks kind of nice. And you could have, later on, we're gonna start to learn about how you analyze this image, that once they are in the code, you can analyze them by calculating features and running them through a neural network and so on. That's what we're going to talk about throughout the rest of the semester. Okay, so we have Excel. Now we have Excel example. Now let's look at a little bit small now. Hopefully it's still readable. If you zoom out, because I share the high resolution, if you zoom out, I mean, you maximize your screen to be able to see the numbers. But here, you might not really need to see. Maybe I just maybe make it a little slightly bigger to 125, see what happens. 125, maybe it's slightly more. So anyway, let's talk about Byte Image array. So if I recall, for Byte Image array, I have a really long array. Okay, kind of long. I'm not gonna tell you how long this is yet. So, but I told you the width is 32. And how do we arrange this into a Byte Image matrix? So if I do it by hand, I'm gonna do like this, which is very tedious. Okay. 0, 0, 0, 0, 0, 0. I had to write 32 of this and then do it many, many times until I exhaust all the data in the image array. Or I can use the Excel just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, and 2. Okay, this is 32 of this. So I copy that over here, and then I come over here and just do another time. 1, 2, 3, 4, 5, 6, 1, 2, 3, 5, 1, 2, 3, 5, 1, 2, 3, 5. And I'm kind of getting tired of it. It's pretty tedious to do so. And then so that's why we have to learn. We're trying to write code. And we've been talking about using wrap rows. And so in fact that in Excel we have a built-in function called wrap rows. Okay. And then I will go back up to select a whole row of numbers. Let's allow this. And then I'm going to select and can specify how many I want to wrap it around. Let's just say for sake of just do a 16 for now. So for maybe not 16, let's do 64. So we'll have an image look like this. Does it make sense to you? Does this image, can you tell what this image is yet? Okay, probably not. So there's a lot of small number, different intensity values. So this one, they showed the palm sign because the font is kind of too big to fix into the cell. So what I'm gonna do is I'm going to change the font to something smaller. So maybe here, so you can see the number. Oh, so indeed it's a valid Byte image. In fact, I haven't seen any. I don't see any value that is bigger than 255, right? Okay. So anyway, so I have this, but in order for us to see it, so maybe I actually created this conditional color using this technique to be able to show that map 255 to the bright pixel that white. And if I change it to 128, it becomes darker. Change to 0, it becomes black. So I have that prepared already. So I have this cell. I could copy this picture over here to see whether I could see what does it look like. Okay, I copy the whole picture. Okay, whole picture. I do it kind of quick because I'm pretty good at Excel by now. So if I copy and paste over here, it makes, wait, doesn't let me. Okay, one more time. Maybe I didn't press it correctly. Okay, I Control C to copy, and then I go back here, but I want to paste this, but I want to paste it only the value, not the formula yet, not the like a format. Okay, so I have something like this. What does it tell you? It's actually sort of like look like, what does it look like to you? It looks like an Instagram icon to me for some reason. But then but then on the right hand side, if I copy, I'm going to copy this format to so that I can see. I copy paste all the format here. So another Instagram kind of like this, but it seems kind of weird. So maybe 64 is not the ideal width because I already told you 32. If I do 32, and then I got a more square sort of image, and then put them together. I'm gonna copy this value one more time, but I'm going to fill it in over here again. Okay, then I'm going to paste all the values. So we have a bit more well-structured Instagram pictures, but maybe I'll delete the right-hand side. So this is my Instagram picture. So the image array is such Instagram picture. So then how I delete this? Let me delete this. I found it distracting. Okay, so I won't delete this, just delete. Okay, all right. Okay, and so if you sometimes you messed up on the width, for instance, I have 32, what's gonna happen? It's get a spill, maybe let's do a 30, say 35, okay? So now it's 32, you can see the whole image kind of shifted. So that's a very typical pattern when you actually messed up on the width, you will get this like shifted picture. And it's still hard to see. So I just copy all this value into my color scale so you can see the effect. Okay, I just copy and then paste into this place. Again, I'm pasting the values. I paste in the values, not just the color, because if I paste the color as well, it goes all white. You can see that it kind of looks kind of messed up Instagram icon, look like this, very ugly. Okay, so I just going to undo this, so I still get my Instagram icon back. Okay, so this something I will so I'm will be you'll be able to, well, you have access to this spreadsheet, you can play with it yourself as well. All right, and so next I'm going to extend this example to a color RGB example. So to talk about RGB image array. So in this case, this is going to be the same image. And so this is a 32 by 32 image. This is a square image I told you. So this is 32 by 32. So I type 32 by 32. Okay. And then how about my RGB image matrix? I know this is going to be 32 by 32 by 3. Okay. So let me just fix this a little bit. Okay. So it's more square. It's prettier this way. Okay. So 32 by 32 by 3. And then, and something we have to, again, agreed upon, assuming that the color order is going to be RGB, RGB. And then if we like to go back to arrange into LED matrix format, they can be displayed. So I actually just want to map RGB here, kind of like this. So this is 1 pixel RGB here. Okay, so RGB here. So this is my plane. So I just erase this. How can I implement it? So I'm just going to be copy here, paste here, copy the first 3, copy here. Okay, so this is the second pixel, all right? And this is the third pixel. So you realize what I'm doing is just going to be copy the whole thing, like whole row, but with its order. Like we're going to copy the first row going to be 32 of this group of 3 numbers. Okay, so in fact that I'm just going to wrap by 32 times 3. That's what I'm gonna wrap the rows by. instead of just 32 by 3. So now I can write this equation formula using the same rep row. This is my planes, rep rows. And then I select the whole data array. But this is a difference. Instead of 32 only, but I gotta do 32 times 3. So there's how many values? That's 32 pixels per row, but I have 32 times 3 number of values per row in order to arrange this properly. So now I have this one. Okay, so you can see that if I zoom out, you can see a little bit Instagram-like. Let me just see if I can zoom out a little bit. Because this, when I zoom out, usually it's kind of small. I hope I'm not gonna crash this. Okay, not too bad. You can see a little bit Instagram shape, okay? And now I have prepared a color mixing pixel like this. So every 3 of this is a pixel. Every 3 of this is a pixel. But each pixel has 3 different primary colors. That's a plane. I want to let this out on my Excel sheet. Hope that kind of makes sense. So this is these 3 things. So I'll already individually map them into a particular color. So you can see, I can play with this a little bit. So now I put 255, 255, 255, 255 in this case. But if I change to 0, 0, it's gonna be black for the other channel, okay? So this is the conditional formatting of this particular cell, all right? And now I want to do is that I would like to make sure I can color all this so I can show you the effect. So I'm going to copy the entire, I can select, now I selected the entire color RGB image matrix, which is 32 by 32 by 3 matrix, okay? And Control C to copy this value. And now I'm going to come down here and paste this. Oops, not the paste. I will need to do a spatial paste, which is Control O and V. And I bring out this. So I'm going to paste only the value, not the style. Otherwise, I'll replace style. Now I can get this. Okay. So this is the what if you stick your head really close to your screen to an Instagram icon. That's what you will see. But in reality, if I could just continue to zoom out a little bit, you can see that the color started to mix when they get really close. So I can show you. I hope that won't crash this. They do a 25%. See, okay, you started to see that they are color and mixing getting next to each other. Now we just do a say maybe do a say 10%. See what happened. Either it works or my expression crash. Okay, here. So it's starting to see the little, if it's from my eyes, it's kind of brownish a little bit on the upper right corner because the color started to mix. But if you could push your chair behind kind of like this to your screen, you can start to get to some point far enough, you can start to see the color really mixing down together. So this is how we are simulating the LED screen to display color images using Excel while being able to get you down to a low level computation to make this image RGB representation possible. And so now doing 10% zoom, they can do, let me just try 5%. Hopefully not gonna crash. 5%, let's say 5%, see what happened. The number must be between 10, okay, cool, can we do this? I wish there's a way I can just zoom further out for you to see the effect, but I think there's as much I can zoom. Although I think it'll be fun for you to play with using your computer at home. All right. Okay. So this is all I like to talk about for the first lecture image, and so hopefully by now you kind of have a bit more taste of what's to come. That there's a way that I would like to take you throughout the semester that we get to more advanced topics, all the way to vision transformer and OpenAI's clip model to talk about multimodal modeling. Hopefully we can get you far enough. And that semester we've been so successful. Most students are able to build architectures from Excel format, they build transformers and convolutional neural network and so on. I think you can too.